Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Okay, I'm going to continue with part 4. Again, I will be only concentrating on questions that most of you are unable to answer correctly. So the first one here is, we've got a diagram here. ABCD is a rectangular field. C is due south of A. Okay. AB is equals to 450 given BC is equal to 210. Martha walks an average speed of 5.2 km per hour. Calculate the time Martha takes to walk once around the perimeter of the field, giving answer correct to the nearest minute. Given speed is 5.2 km per hour. Okay. This is a question asking for time. However, we don't use the timeline here because you are given speed. That means we use the DST rule, the ST ratio. You need to memorize this one. Okay, DST. That means question is asking for time. So time is equals to distance over speed. Just follow the triangle there. Distance. So distance around the perimeter of the field. That means it goes 210, 450, then here, and then here. Okay, because this is a rectangle, that means opposite sides are equal. So distance would be 210 plus 210 and 450 plus 450, and then the speed is 5.2 kilometer per hour. But bear in mind that the unit for this one is in meter. So when you do calculation, make sure that you do need to convert it into kilometer. That means you divide that with 1,000. So 2 times 210 plus 2 times 450, that gives you 1,320. So let me just put it here. Okay, and you divide that by 1,000. So suddenly when you divide that by 1,000, it's no longer a meter, it's a kilometer over 5.2 kilometer per hour. So use your calculator, divide that, and with 5.2, you should get something like 0.253846 so that is in hour. But since the question is asking for minutes, all you have to do, just press the time button and it will give you the minutes. It's equals to 15 minutes, just like that. Okay. Show that the bearing of D from A. That means at A you need to have the north line going towards D. Translate that into the diagram. So let me erase this one. Translate that into the diagram. We have the north line there. Let me just extend that one. And then from A to the line where it connects to D. So that is what the question is asking to find. Can do, because say C is north of A, extend that, what we actually get is a triangle, and this is a right angle triangle because it is a rectangle. we know the sides here 210, and let me see, let me use a different color. This angle here is 180. If you're able to find this angle here, we can just add that both angle together and we can get the bearing. So suddenly it transforms to question on, let me just rearrange that one. So that's 450, that's 210, and the angle at A is what we want to find. So this is the trigonometric question. Trigonometric question. So the hypotenuse is here, the side where both angle R is the adjacent. That means the remaining side is the opposite angle. So that means we're going to deal with A and O, which is TOA. Now, translating it to here. I'm using a green. Tangent theta is equals to opposite over adjacent. Tangent theta is the one that we want to find. Opposite is 450. Adjacent is 210. Using a calculator, making sure you find the inverse tangent. Should get, so this is not your final answer, so don't write it off early. Let's have some digits there. I think that's enough. 8310. 31 is enough. Okay, that means the bearing would be the 180, the straight line, plus 64.9831. Okay, look at the diagram. So we found the yellow bit here, 64. You add it with 180. And you get 244.9831, but it says correct to three significant figures equals to 245. Sure. PQR, next one, PQR is a triangle and S is a point. So PQR is triangle, S is a point of PR. Nothing that says midpoint anything, so no assumption. What is given is PS is 10.3, QR is 12.6, QPS is 4.2, QRS is 35. Calculate QS. So the question is asking for QS here. Definitely a triangle problem, nothing got to do with area, nothing got to do with perimeter. So a triangle problem, that means this is trigonometry, so either you use a Pythagoras theorem or trigonometric ratio. However, here can't use Pythagoras theorem because there are no 90 degrees, so you can't use that one. So our next option is by using trigonometric ratio, which means you either have to choose between sine rule and cosine rule. To find QS here, let's look at this triangle here. To find sine rule, it can't because you only have one angle here. Sine rule, you need to, if you're using a side, so you need to have two angles and one side. we only have one angle and one angle and one side, so you can't use the sine rule here. Cosine rule, if you want to find the side, have a squared is equals to b squared plus c squared minus 2bc cos a. We need two sides, b and c, and then an angle. We do have an angle, but we only have one side, so it can't be used as well. If you look at this triangle, same thing. It is quite difficult to find it. So what options do we have? With the two angles that is given, so we can look at the bigger triangle. So you have the 42, 35. That means we can find the angle here. So angle PQR is equals to 180 minus 42 minus 35. We are just trying out, see if it will help us in getting our unknown side or unknown angle to find QS, because we don't have enough data to be substituted into the formula. So we have 103 here. Does that help? It helps in a way, because if you look at the bigger triangle, we have two corresponding values, 42 and 12.6. That means 103 and PR. So we can use that one. Okay. So instead of finding SR, we find PR. So PR over sine 103, 12.6 over sine 42. Multiply both sides with sine 103. Let me write that down. Using a calculator. Should get, hold on, 12.6 divided by sine 42 times sine 103. Again, this is not your final answer, so don't write it off yet. So I have enough digits there. Finding my PR, that means my SR would be 18.34778 minus 10.3. 8.04778. Okay, now, so putting that there, so that means for this triangle, I have two sides and one angle and a side that I need to find. That means I can use the cosine rule, because cosine rule, two sides and one angle. Okay, so where do I put my working here? So let me just write here. QS square is equals to 778 square plus 12.6 square minus 2 times. Don't worry, when you have a lot of digits, you are using your calculator. This is just to make sure that you are substituting the right thing, so that when you use your calculator, it'll be easier. So use your calculator there. 2 times cosine 35, and then you have equal. So QS square is equals to 57.39939. Taking the square root, QS is square of both sides, 7.57624, and that's your final answer. That means you can give now your answer correct to 3 significant figures. 7.58. So this is one of the variation that you can use. You can use cosine rule, a sine rule first, and then cosine rule, or you can use cosine rule first and then find and then use sine rule to find the value. Either way, you should get the answer. You should get the answer QS is equals to 7.58, correct to 3 significant figures. Question 18. So this is the volume and curved surface area. Okay, solid is formed from a large cone with a small cone removed from the center. So the center is hollow. The small cone is mathematically similar. Now that's very crucial, the word similar there, because of a lot of things. For similar shapes or similar solids, the ratio of corresponding sides are equal. The ratio of corresponding surface area is equals to the square of the corresponding the square of the ratio of the corresponding sides, and then ratio of the corresponding volume equal to the cube of ratio of corresponding sides. Height large cone 21, diameter 18. The height of small cone is 14, so it's not given, so we should put it in there. It's from the center, 14. Show that the volume of the solid is 399 pi. Now see here, it's given as pi. That means definitely we use pi because all the formula uses pi. That means you have no need to substitute pi as 3.14 or 22/7. Just leave it at pi. Treat it like just a variable x. Okay. Volume of the solid, that means volume of the shaded bigger solid minus small solid. So the bigger solid, the volume of the bigger solid. So volume of bigger solid, 1/3 pi r square, 1/3 pi. So the bigger solid radius would be 9 square times by height, which is 21, minus small solid, same formula. However, radius we do not know. But we do know that. So we can't actually proceed here unless we find pi. Unless we find r, radius of the small solid. So radius of the small solid, we can use the similar properties. Okay, so the diameter of the small solid over diameter of the bigger solid equals to the height of the smaller solid over the height of the bigger solid. Multiply both sides by 18, and you should get the diameter of the small solid is equals to 12, which we can now replace that with 12. Simplify this. So 9 squared times 21 divided by 3. For the first one, you will get 567 pi. Leave pi as it is. And don't forget it's square. That's where the common mistake is. I almost made that. Oh, no, it's not 12. Sorry. Diameter is 12. That means radius is equals to 6. So it should be 6 square. Sorry about that. 6 squared times 14 divided by 3, and you should get 168 pi. So 567 minus 168, and you get 399 pi. So the word similar here is very crucial because you can use that one. Another option which I have shared before is you can use the no, you cannot. Scratch that. Okay, so use the similar shape. Calculate the total surface area of the solid. So total surface area of the solid is the shaded area on top plus the curved surface area. The curved surface area is given pi RL. Okay, pi RL. The shaded area is big circle minus small circle. Okay, so big circle pi times 9 square, small circle pi times 6 square. Again, for this one you still can leave it pi first, so you don't have to deal with pesky decimals. That will give you 45 pi for this one. And then pi RL, you have the pi, so the radius is the bigger circle, hold on, it's the total surface area. So okay, surface area big plus inside curved surface area small. Okay, just the same thing. Pi RL. So the radius of the big is 9 times, you don't know what L is. Same thing with this one, pi times 6. We don't know the slanting height of the bigger one, slanting height. So the slant height for the bigger one, for the smaller one, that's 14, and we know that is 6. So this is the slant height, which if you see, that is a Pythagoras theorem question. So 614. So moving here, in order for me to find that, I need to find my L first. So let me here 14 square plus 6 square, so L is equals to square root of 232. I can leave it like that, that's fine. Okay, so that means pi times 6 times square root of 232. For the bigger one, I can use the same thing. I can use similar solids as well, property similar solids. But let me use Pythagoras theorem, because I have 9 and I have 21. Oops. So 9 square, 21 square. So L would be 9 square plus 21 square root. So square root of 522 plus pi times 9 times square root of 522. You do, it's quite lengthy. It's worth 6 marks. So having labels in your working, it helps a lot. So after that, all you have to do is just putting everything in exactly as what you have written down. Just use the pi or your calculator, the symbol pi in your calculator. Okay, and then sign should get something like that, and then give you 170 for 3 significant figures, because the answer is not exact. Okay, so a few things happening here. So writing those labels down is very crucial. So if you look at here, it's B, that means it has got nothing to do with the question above. The height of a cylinder is 13 centimeter, correct to the nearest centimeter. The radius of the base of the cylinder is 4.5 centimeter, correct to near 0.1 centimeter. Calculate the upper bound of the volume in cubic centimeter of the cylinder. So what is given here? Volume. Volume cylinder requires you to multiply the area of the base, which is a circle, multiply by the height. That means since we're doing all multiplication here, that means all the value need to be in upper bound. So find the upper bound of the height, find the upper bound of the radius, put it into the formula, and you get the upper bound of the volume, because it's multiplication. So height, 13 centimeter, the nearest, so nearest will be 14, means 12, that means the upper bound is 13.5 for the height. So the height is 13.5. Radius 4.5, 0.1, that means the next one is 4.6, means here is 4.55. So the upper bound is 4.55 square. Put it in the calculator, calculate it. Oops, I pressed correct incorrectly in my calculator. And you should get 878.0240958. Three significant figures, 878. Okay, right, then we have that. Which one? This one is most of you are able to do it. Okay, so that will be